My name is Liebert and I'm a physiotherapist from Australia, and I'm currently undertaking a PhD at Sydney University. A little bit of history of my experience with laser. So I've been using laser since 1988 because the Russian physicist Tina Carew came to Australia, and we were introduced to laser and how effective it was for the injuries in Chernobyl. And we borrowed a laser at the practice I was working at, and we found that it was effective in treating people that were unresponsive to other conditions. So that was in 1988, and I've had my own practice since 1990 for 25 years. And the first thing I did when I opened my practice was buy a laser treatment. So originally the lasers were very low dosage, but now since I've been introduced to the more modern lasers, the treatment techniques have been much quicker and we've been getting much bigger results. So in the year 2008, I was introduced to a researcher, Dr. Roberta Chow, who had also had the same experience as me with lasers, and she was a pain physician, and she wanted to know why her patients got better with laser rather than acupuncture or normal medicine. And so she undertook to do a molecular genetic PhD, as you do. So she enrolled at Sydney University, Brain and Mind, and got some animals, dorsal root ganglion, and put the laser on it, and then had to see what the effective treatment was. And she discovered back in 2007 that the laser caused a cytoskeleton modulation equivalent to a lignocaine injection block. And there was a complete neuro blockade with little varicosities, and this was what had stopped the pain. This was a real epiphany. It was published, and as a result of that, she started working on a meta-analysis and a trial for the Lancet, which was also published. So in the meantime, she approached the physiotherapy profession to share this wonderful new treatment and the mechanism and the new research. And I was the only physiotherapist in Sydney that was interested, so I got wrapped into the laser world. So she lent me a Neradia laser at the time, which was her laser, for 4 months to find out if this would be a better laser, because I was going to buy a new laser. So I had to give it back to her at 4 months, and at that point I went over to Sweden in 2009 and did a sabbatical in Sweden with my husband, and went to meet Jan Bordel and Lars Hose on the advice of Roberta. That time I was then introduced to the laser research world. And as a result of my being lent this laser, there's no such thing as a free lunch in Australia. I had to give a talk about laser and physiotherapy to the AMLA group in Australia. So I did that on my pet subject, which is cervicogenic headache. And in that time, I decided that cervicogenic headache was a problem with ion channels, and it was a hemiplegic channelopathy, the same as familial hemiplegic migraine. I was the only person that thought that. It was 2 years later that they found out migraine with oral was a channelopathy, and a physician came up to me, Dr. Kevin Lowe, and said, "I think you're right, Anne, I think it's more common in Asian races." From that point, I did my sabbatical, and I decided, because the physiotherapy profession in Australia was ignoring this wonderful new mechanism, that I would undertake to do a PhD at Sydney University in unresponsive cervicogenic headache. So 25% didn't get better with physiotherapy or radiofrequency neurotomy or a cortisone injection or surgery. But of that 25%, 80% got better with laser. And so I decided to investigate why, because I wanted to know. So in the meantime, Lars Hode in Iradia had asked me if I could do a trial on people with different skin types to work out the equivalent dose equation for fluents. So I said that I would do that. So I approached Sydney University, and I chose a non-physiotherapist to be my supervisor and said, this is what I want to do, unresponsiveness and why laser would produce responsiveness. I said, Anne, you can't do this at Sydney University, you will have to do the laser research down at Canberra University, and I will undertake to do that. And you can do your cervicogenic headache research at Sydney University, and then we will see what happens. So unbeknownst to Sydney University, I did 2 years of laser research, and I got ethics to do Lars Ho's trial that he asked me to do down in Canberra University. And then when I started publishing this, the Sydney University found out, and then I combined it to be a PhD. So what I found was a complete linear dose equation for Fitzpatrick's scale in laser. But during that time, I found out there was melanin in the spinal cord, which I didn't know, and in the brain. So I said to my friend Roberta Chow, perhaps we are effectively treating the spinal cord, the melanin. And he said, no, Anne, the laser works on the cytochrome C oxidase in the electron transport chain. So why would it have anything to do with melanin granules? It wouldn't be possible. And I thought, I don't know about that. So I had a look what actually broke down to form neuromelanin. Neuromelanin is different from melanin in the skin, which I had just done my study on. And people that are albino have melanin all through their spinal cord. So I thought, all right, what breaks down to form neuromelanin? Because it's not there at birth, it happens 3 days after birth. So I had a little look at that. And what breaks down is norepinephrine, epinephrine, dopamine, all the catecholamines known to man. So they're the neurotransmitters. So then I had a look, is the active spectra of the catecholamines absorb light? Well, yes, it does. And in this research, I also found that when we release infrared heat at 97.5 degrees because we're warm, we also release all the other visible and red light and blue light wavelengths of laser. And then I found out that all through the brain and through the spinal cord, there's receptors for light called encephalopsins. And I thought, okay, we have got light, we have got receptors for light, maybe we have got an endogenous mechanism that we have just tapped into and cracked the code. So at we had a big WALT conference in Australia, so I did a study on ion channels, which is how the laser works on the potassium channels, and looked at the possibility that the body might be having some communication with light endogenously, and that's why the laser worked. And I talked to my supervisor at Sydney University, what should I do? And he said, Anne, I think you should write a medical hypothesis. You should downgrade what you're writing in the WALT proceedings and write a medical hypothesis. And I said, okay, Roger, in your 290 papers, have you ever written a medical hypothesis? No, Anne. Have any of your 23 PhD students ever written a medical hypothesis? Well, no. What makes you think I can? And so he said, you should do this. So I spent 1 year writing this, looking at the mechanism that could be possible, and I wrote it, I sent it off to medical hypotheses. After 3 months, we didn't hear anything. And at that 3 months' time, we wrote back and emailed them and said, what's happening? And they said, we're thinking about it. And then within 3 days, I got an email message saying, we are putting this on the internet tonight as an unedited paper, and you have got 48 hours to edit it, of which was not much time, so it ended up with a few spelling mistakes, and it was put on the internet 12 months ago in December the 20th. 5 days later, a group in China published a really high-powered journal article of photomedicine and photobiology about the mechanism of biophotonic transmission communication in the body, of which some of their work I had used as an argument for my medical hypothesis. And they had reviewed all their own work and said, we know that this would happen, but we don't know the mechanism, so we would need to do more research about why. So mine said, if this were true, this is how laser works, this is how biophoton works in the body, the things in common are this, therefore this would be the mechanism. So mine got piggybacked onto the very good, respectable paper, and it went viral in the signal transduction labs in Europe. So then I was asked to write another paper for signal transduction insights about anything I liked. So I'd already worked out some proteomic aspects of what the laser might be working on. just through clinical experience. And so I said I will do a paper on prion signaling in the nervous system. So I did that in 6 months, of which I had to get the assistance of my husband, Brian Bicknell, who's a molecular geneticist, to help me write this paper on prion signaling in the nervous system, which was then published and well received. In the meantime, I was asked then by a proteomics conference in China, Protein and Peptide Conference. First 11 people had the Nobel Prize to do a keynote speech in a hot issue. So I actually, well, my professor did, so I actually went and delivered that, and it was well received. As a result of that, my professor got invited to the next World Conference to give a keynote speech in the hot issues. So we're not saying it was right, it was hot. It was the Kim Kardashian of the latest laser research. And so the person who was the head of WALT, so Walt Nolt invited my professor, was Lisa Laxo, who is in Australia. And so I said to her at a course we were running together, do you realise that you have invited me to go to be the keynote speaker at your conference in the hot issues? No, Anne, we've asked Professor Roger Adams, and he's at Sydney University. And I said, yes, and he's my supervisor. He wouldn't know a protein if you fell over one, doesn't want to give it and can't. And if you want it, I can give it because I've just given it in China. So they said, I will make a point that you get the invitation. So at that point, I went to see 5 different physicists to try and make sure what I was saying was not politically incorrect. My husband, Brian Bicknell, who was a co-author, got time off his university to go to Walt to help me give this paper in Walt. And I did that, and it was very well received, and I got an award for my poster, which was conceived of as being for my talk. So that was a good thing. I have been also doing my laser research in my cervicogenic headache, because 25% don't get better with physiotherapy. Of that 25%, 80% from Roberta's work get better with laser and treatment. And so I wanted to know why. So I looked at the proteomics of the cytoskeleton changes that Roberta has seen. And so I looked at what endogenous mechanism is involved with those normal varicosities, and I found both in poisoning and in hibernation and in migraine, the same neuroprotective varicosities occur endogenously. So I then looked at what particular proteins were modified endogenously that we could be modified in the laser treatment. And as my next postdoctoral fellowship, I'm going to go into the lab and investigate the proteomics of the cytoskeleton modulation. In the meantime, I had done an intergenerational trial on my headache patients to find out which of these features in headache patients were maybe running in families, because I had 2 and 3 generations between 5 and 93 of patients that had had headache and had had treatment and had responded. So I looked at 50 variables to see if they were different between the groups. And to 0.02 in repeated measures, I found out that the headache patients who were in remission, I might add, because they'd had treatment with laser, had completely different single leg stance compared to the relatives that never had headaches, and this was statistically significant. And so then I looked at the proteomics of what I was going to do in the lab. I looked at the antibiotics for the 2 proteins that I'm going to look at, PSD95 and prion, and then I looked at what they are the molecular determinants of, and they are the molecular determinants of balance. So this is why I think the patients get better with laser when they don't respond to other treatments, because we are able to change some potassium channels and some proteomics, and that's for future research that I'm going to do. In the meantime, I'm hopefully completing my PhD and looking at some other mechanisms that might be behind the cytoskeleton, and I have published this as a medical hypothesis, so this is only a hypothesis. So there are 1,000 different proteins in the body. There are 30 different functional groupings of proteins for differentiation or signal transduction. Some proteins have similar actions. If a protein has the same action, it will resonate at the same frequency. If the protein has a different action, it will resonate at a different frequency. Proteins can have more than one action, so proteins can resonate at more than one frequency. The proteins I'm looking at are intrinsically unstructured proteins that wrap around other proteins to form a signalplex. So if you've changed a protein structure, you will be able to resonate at a different frequency. As in tuning forks can be changed if you change the tuning fork parameters. So this is an area that I think the laser is able to work in, and it needs a lot of investigation. So we know from Kojich's resonance consonant that proteins can be predicted to have a different resonance according to its amino acids, and this lady in the 1990s worked that out. So she had lots of proteins and she worked out the amino acids and the resonance spin, and she worked out a consonant for the different function. In the meantime, there's a group in Canada that have looked at this. They got some melanoma cells, they put them under stress, they took them out of the incubator and put them in a petri dish. After 5 hours, they started to engage in signal transduction so they could communicate, and they started releasing infrared at 950 nanometers, which was exactly the same as the predicted Kojich's consonant. Then they die. We release ultraviolet twice on conception and death. They actually then release 280 nanometer ultraviolet, and then they release during the decay process lots of other frequencies of infrared and red light. And this group augmented the process that the cells were undergoing by adding chemicals according to Kojich's consonant, and within 5 nanometers she was on the money. So this is a way that we may be, when we're treating people and they get better with repeated treatments, changing the resonance of the proteins that are dysfunctioning, but that will be for further research. I thank you for your attention.